Glad you could make it on this kind of hot and smoky night. Uh, for those of you who have never attended one of these events before, my name is Brian Jackson. I'm a professor here in the Physics and Astronomy department. Uh, this is the first Friday Astronomy lecture series. These take place on the first Friday of every month, 7:30 p.m. We are supposed to be in this room for the coming foreseeable future. As you probably are aware, we sometimes get moved. Okay, but I talked to the associate vice president for operations, and I think we've confirmed that we're going to be in this room for the fall. So if you want to join us, first Friday of every month, 7:30 p.m., we should be in this room in the coming fall semester. These events, if you've never attended one, are really excellent. We've had a really great series of speakers come through. We bring in space scientists, space journalists, space policy folks to talk about all kinds of things related to space. These events are entirely donor supported. We do not get any state funds or university funds to support this program. So if you want to help to support the program, you can zap this QR code here. It'll take you to our donation page. I can also take cash out front if you want to donate at the table. So all of that money is what brings our speakers in from all across the country. I think I've said this several times, but this coming fall will be the 10th anniversary of the First Friday Astronomy Lecture Series. It's kind of hard for me to believe that it's been 10 years. I was just telling some of my students today, we've actually had children grow up in this room. There's been kids who started 8 years old sitting in this audience, and then they're going to college this fall over the course of this series. So it's crazy how long that's been. And so in celebration of that, we've got a lot of fun things coming up this fall, including a really great lineup of speakers. So the next month, we're going to have Jack Carrolley from the Planetary Society. This is the group that lobbies the government for space science support. And so if you want to come hear about space policy, September is a good month to come. And we've got scientists coming in from the Artemis mission. We're going to have folks involved with the Dragonfly mission. So there's a lot of really, really great speakers coming up in the fall. So please do join us for the fall event. Another update is our on-campus observatory is very, very, very nearly complete with its renovations. We have some alignments that we have to do to make sure that the newly automated dome and the telescope are talking to each other, but we're scheduled to do that in the next couple of weeks. And so my hope is, the plan is, for that September 1st Friday, we'll take folks up to the observatory and show you the newly renovated facility. That's up on top of the education building. So that first Friday event in September, we'll have to march down across the quad, which will hopefully not be under construction at that point, and we'll take you all to see that newly refurbished observatory. Okay. So with that, I'm very proud to introduce tonight's speaker, Leah Rogers. Leah is an alum of the Physics and Astronomy program, was in my astronomy classes, did very, very well. And she's been, since she graduated, an AmeriCorps member with our outreach program, and served as, I think, their very first night sky conservationist. They've never had anyone in a role like that before. And so she did some really amazing work supporting our outreach and astronomical observing program. She's going to tell you about some of that work tonight, and I think you're going to really enjoy it. So with that, let's welcome our guest speaker, Leah Rogers.
Okay, cool. Alrighty, thank you, Brian, for that introduction. I am Leah Rogers, and as he just said, I am a recent graduate from Boise State University. I studied astrophysics, and for the last year, I have committed to a year of service under AmeriCorps, doing conservation of dark skies in Idaho. I didn't know what AmeriCorps was when I first kind of heard of this position. I first heard of it when my best friend had this position before me. So by raise of hands, how many of you have heard of AmeriCorps and know what that is? Okay, cool. We have a few people. For those of you that don't know, that's okay. I'm going to explain it. So, oh, 1 second. Oh my gosh. Technical difficulties. Okay, AmeriCorps is a service-based agency that provides grants to state and local organizations to tackle community needs. So we have AmeriCorps members across Idaho that help with educating young kids about how to read, how to do math. We also have AmeriCorps members in the 4-H group. I specifically am a part of PCEI, which is the Palouse Clear Water Environmental Institute, and we specifically focus on environmental education within Idaho. So including me, I have about 7 members within my cohort, ranging from Moscow to Boise. So down here in the valley, we have 2 environmental education instructors in the Boise Urban Garden School and the Foothills Learning Center, and these folks help go to what's the word I'm looking for here? Underrepresented schools to educate younger kids about gardening, food, the foothills and the area around them. We also have an outdoor science lead at the Moscow Adventure Club, and I believe this member works specifically with students between 3rd and 5th grade, and they take them to the outdoors and teach them how to be safe in nature and look at really cool things. We have a trail ambassador in Moscow Area Mountain Bike Association, which is MAMBA, and they help bring people on mountain bike rides through trails and learn about trail safety. We have another member in wildlife education at the MK Nature Center that teaches people about the flora and fauna in our local area. And we also have a volunteer services coordinator at the Peregrine Fund that facilitates volunteers, their different programs, and helps make sure that they have just a good time doing their volunteer service. So my specific role is the night sky conservationist. And so the main point of my position was to raise awareness of light pollution through community outreach, as well as help research and track light pollution. So the first part was really simple. I help with outreach, focus to engage groups outside of academic settings, kind of like the seminar. And the other side of it was a little bit more difficult with tracking light pollution through research. And we do this through a sky quality meter and a camera in tandem, and I will get a little bit more into that. But this picture on the left side of the screen, this was taken when I was doing one of my sky quality meter reading nights, and I got our lovely gator here stuck in a bunch of tumbleweeds. And my friend who was with me to help, instead of helping me get the gator unstuck, decided it was time for a photo op. So that is some of the really cool stuff I get to do. But now on to the meat of my position. Why do we care about light pollution in the first place? But before we start understanding light pollution, we need to understand where it comes from. And this is coming from Rayleigh scattering. So Rayleigh scattering in itself is not inherently bad. It is just a physical phenomena that happens in places that have an atmosphere. So here on Earth, our atmosphere is mostly made of nitrogen and oxygen. And nitrogen and oxygen has a resonance frequency with blue and violet light. And so when oxygen or nitrogen is hit with this frequency, they start to wiggle, and then they emit light out in all directions. And so this is the Rayleigh scattering. This explains why we have blue skies and why we have red and orange sunsets. So as that scattering has to travel further and further through our atmosphere, it'll slow down and it'll turn into those red and orange colors. And this is why Mars has a red atmosphere. So carbon dioxide makes up most of Mars's atmosphere and has a resonance frequency with red light. And the moon, like this picture right here, has no atmosphere, so little to no Rayleigh scattering happens. And this is why shadows are so stark and kind of cold on the moon. So this is where Rayleigh scattering kind of causes a problem. For us, during the daytime, it is totally fine, but at nighttime, it can cause light pollution. So light pollution is caused by the scattering of light from artificial lights at night. And with the advancement of LED lighting, which is moving more towards the blue side of the spectrum and the whites, it's only getting worse. On these images right here, we have a few examples of light pollution. So in this left side picture, we have clutter and glare. And clutter is a form of light pollution where there's just way too many lights. We could probably do without half of these light posts, but they're there for aesthetics. And glare is when light is kind of shining right into your eyes. So it's not shielded whatsoever or pointed towards areas only where it's needed. So we have light going straight up into the atmosphere. We have light going everywhere. And on this right side of the screen, we have sky glow. So sky glow is when a large community, city, or town emits a lot of light into the atmosphere and causes the surrounding air around it to glow. And it can be seen from miles and miles away from where these communities are. There's one more form of light pollution that isn't really kind of visible in both of these pictures, and it's called light trespass. So has anybody had, like, you're trying to go to bed at night, and you open your window, and then your neighbors have that one light that's just always going into your room, and it's really annoying? That's called light trespass. And it's also a form of light pollution. So other than being visually problematic, light pollution can cause a lot of problems. The impacts of light pollution can range from ecological, waste of energy and resources, as well as washing out our night sky. So ecologically, nocturnal animals' patterns are heavily impacted. Predator animals have their hunting patterns changed, so they will either avoid areas of light altogether, or they will gravitate towards areas that have light to get easy prey. Prey animals might gravitate towards the lighter areas so that they can scavenge longer and end up being preyed upon a lot more. And this can really disrupt those like predator-prey relationships. The largest animal group that is affected by light pollution is birds. So birds use the night sky to determine their migration patterns. And now with large cities having so many lights, those birds will get confused and they might migrate actually towards those towns. And this can lead to a lot of bird deaths, and they're probably one of the most impacted. But us as humans are also part of this ecological problem. So we have a circadian rhythm, which determines our sleep and wake cycle. And when we are exposed to artificial lights at night, our circadian rhythm is altered. So if you stay up late at night, your body decides not to produce as much melatonin to keep you awake because you're seeing all these lights. And that can make you sleepless. It can give you insomnia. You can wake up groggy, and further down the line, it can cause a lot of health issues. But there was a really cool recent study that found that nurses working during the night shift had large hormonal imbalances due to not producing enough melatonin, and this led to a higher risk of developing breast cancer. So we are definitely not safe from this problem. It still affects us. But the whole reason behind my position ends up being protecting our night sky. So in this picture, you can see this picture on the right, or I guess slide on the right, was probably taken in an urban area, and that sky is very washed out versus the picture on the left that was taken in a rural area where you can still see all of those stars. So along with this other host of problems, my goal was to raise awareness about this loss of light or loss of dark skies in our urban areas while highlighting the beauty in the protected areas. Protecting our night skies not only ensure the safety of ourselves and other creatures on the earth, as well as preserving our heritage of seeing the night sky as our ancestors did for millions and millions of years, and possibly preserving that for our future kids. So now we're going to switch gears just a little bit and talk about the science. And I believe that research and tracking is also a part of the solution. So the main solutions are pretty simple for light pollution. It's pollution, or well, light pollution is the easiest form of pollution to solve. It is as easy as turning off your lights. But switching from improper lighting practices to proper lighting practices can really change everything. So that includes shielding your lights so that they just point at the ground where they're needed, using a warmer colored temperature of light bulb, using timed lights that turn off when no one is in the area or they're not really needed, as well as using sensor lights that turn on when somebody does need them. The most important solution to me is spreading the word. So having somebody, relay this information to maybe their neighbors that their light, shines in their neighbor or in their window, or telling their friends and family that they want to change their lighting fixtures. That is really the, snowball that leads into the solution to this problem. But my favorite way of contributing to the solution is tracking these light pollution trends. So these two objects that you see on the right, this one is a sky quality meter, and I forgot my little prop, but sky quality meter is a little digital box that we use, and we just point it straight up and take a measurement And what it does is it measures basically the brightness of a really small part of the sky. It measures things in a magnitude per arc second squared. And if any of you are familiar with what a magnitude is or the magnitude scale, it's just the way that we astronomers usually measure the brightness of something or measure the brightness of a star. So a very, very bright star like Vega or Sirius will have a magnitude of 0. And then an object that is darker and dimmer, like maybe a distant galaxy, that ends up being around the 6 to 10 scale. And then further from that, when we get into these dark sky areas, we are looking for a magnitude of 20 to 22.5. And this signifies a very dark area. However, just having those numbers alone doesn't really represent much, especially with magnitudes being kind of an arbitrary scale. You have to know astronomy in order to kind of understand that. We use in tandem with it the all-sky camera, which is essentially a camera that has been modded out with crazy settings, and then they slap a fisheye lens on it so you can get a 360-degree view of the sky. And then we use this in tandem with the sky quality meter to successfully track all of these things. So these are the areas that I serve in. Idaho has 4 official designated dark sky areas. Those include the Central Idaho Dark Sky Reserve, the Bruneau Dunes State Park. It's the City of Rocks National Reserve and the Craters of the Moon National Reserve and Monument. Those ones are hard for me to remember for some reason. But the Central Idaho Dark Sky Reserve right here on the left, this was the first reserve in the United States. It was designated in 2017 and includes around 1 million acres of dark sky area for people to enjoy and camp and hang out on. And the Bruneau Dunes State Park, which is just south of Mountain Home, was designated as a dark sky park very recently in 2024. And it was designated right after the construction of their research grade observatory. And the Central Idaho Dark Sky Reserve actually just opened its first observatory up there in Stanley, the Sawtooth Observatory, as of last month, July 18th. And this is the Sawtooth Observatory. The main thing that I want to mention about these maps is that there's a few symbols going on. So in the Central Idaho Dark Sky Reserve, we have these little stars. They might be kind of hard to see, but these little stars are dark sky viewing sites. We don't have a map that directly has all of our dark sky meter locations, but some of these dark sky viewing sites correlate to those locations where we take measurements. And you might notice, well, you can't see it down here, but it encompasses from Sun Valley all the way up to Stanley. So that's a really large piece of land. And these dark sky measurements have to be done on nights of a full moon and about an hour and a half after the sun goes down. So it's very dark and kind of scary when you're doing them. And you can imagine a lot of deer like to come and hang out and possibly run across the road. So it's very dangerous work. On the Bruneau Dunes State Park side, we have these little green dots. Those are the locations where we take our sky quality meter measurements. Up there next to the in between the EQ and the B, that is where I got my gator stuck. And then down here next to the picnic area, on my first night ever taking dark sky meter measurements, me and my friend had a mountain lion experience. And we were possibly being hunted by a mountain lion for like 5 to 10 minutes. Who knows? But besides these crazy animal encounters, I was still successfully able to get all of my measurements done. And they end up looking a little bit something like this. So this is a image taken closer to the Treasure Valley area. This was taken in Eagle, Idaho in Avamore, which is about 8 minutes north of Eagle. And it is also a dark sky community. But before I start mentioning any of the features that we're kind of looking for here, I wanted to mention the orientation of these pictures. So the very top of it is facing north. The bottom, which is kind of being cut out by this captioning thing, the bottom down here is the southern. And then to the right is west, and to the left is east. So there's a few different forms of light pollution that we can see going on here. The first that might be really obvious to you guys is this really bright area right here. So that is the sky glow from the Meridian, Nampa, and Boise area, reaching all the way up into a little bit north of Eagle, so a little bit past the suburban area. And then, gosh, you can't see it. it's covered by these. But around this area, you'll just have to trust me, there's a little bit of glare. So there's these really bright dots that are from, I believe, construction happening on the mountain. And I really like this picture because of one obvious, oh, I thought this broke. But I like this picture for one obvious trait, the really pretty pink and green happening. That is the aurora borealis. I took this picture during the geomagnetic storm in November. And the aurora borealis itself is not a form of light pollution. It is just something that affects sky brightness. And researchers like me like to still capture it within these images because it helps us understand how much the aurora can affect the sky brightness in areas. The other thing I want to mention is that there's a lot of clouds in this image. Clouds can either help or hurt light pollution. So in really dark areas in the Central Idaho Dark Sky Reserve, these clouds will be very dark and it'll actually make the surroundings much darker. But in urban areas where there's a lot of light, these clouds get a lot brighter and they reflect a lot more light, making the light pollution a little bit worse. So moving a little bit further away from the Treasure Valley, we have this image taken from the Bruneau Dunes State Park. And the first thing that you kind of immediately notice is that it's gotten a little bit darker, right? You can kind of see that arm of the Milky Way in the middle right here. And that aurora is still present. But we've gotten about 60 miles away from the Treasure Valley area. And right over here on this edge, that glowing section is the sky glow from the Treasure Valley area. So even though we've traveled quite a bit of distance away, that light pollution is still visible. And up in that top right corner, we have those red glowing lights. Those are from the visitor center. They use red lights to minimize light pollution. But you can see that sky glow up there, and that is from the Mountain Home Air Force Base and Mountain Home itself. We specifically are tracking the Mountain Home Air Force Base a lot right now because they are undergoing a lot of development. So they've built a lot of new houses, built a lot of new streets that have a lot of untasteful lighting fixtures, in my opinion. So we have to kind of monitor it and see if it's growing and see if it will affect the park since it's so close to it, right? Now we're going to move a little bit further away. This is in the 4th of July Road in Stanley. So this is about 150 miles away from the Treasure Valley area. And right away, you can see it's pretty dark. You can't see the Milky Way. I took this right as the Milky Way was kind of rising above the horizon. You can see it up there. But we are still about 150 miles away. And right on this side, we can still see some glowing, and that is from the Treasure Valley area. So it's really incredible how these sky glows really can travel super far. And part of our job with tracking and researching it is making sure that either those sky glows are growing or shrinking depending on how light is changing, or I guess how light fixtures are changing within these areas. Finally, I have this last image, which is also in Stanley. This is about 120 miles away. It's Park Creek Overlook. And gosh, I wish I could switch where the caption is, but we'll just work with it. So we can still see that sky glow from the Boise Valley area. And then we also have that sky glow kind of up in the corner. That's from the Twin Falls area. But the great part about these pictures is, one, they're very pretty to look at, but you guys might be wondering, well, how are we turning this into actual data that we can use? Well, that's where we input it into some processing software. So you guys might notice that this last picture and this picture here on the left, those are the same picture. This is the Sky Quality Camera software, and this is what we use to process these images. So I take the pictures, I upload them into this software, and then I give boundaries on where the clouds are, where the horizon lines are, as well as distant light pollution sources. So like maybe some of these glowing dots right here. And then it spits out this really fun looking image. So we mostly work with this image on the left. The image on the right, no one has ever explained to me what it is. I have a sneaking suspicion that it has something to do with color temperature because it has that Kelvin up at the top of that scale, but I'm not entirely sure. So we're just going to focus on this pretty picture. This is the sky brightness scale right here. And we really want our dark sky locations to kind of be within this magenta, or not magenta, violet and blue kind of scale, right? These will give us around a 22 to a 21.5. Those will signify that these are really good dark sky areas. And I need a sip of water. I've been talking for a minute. Sorry. Okay. So you'll start to notice that in the middle of this picture, we have that kind of indigo area. So the top of the, or right over our heads is where it's going to be the most dark. It starts to get a little bit more blue going out, and then you can see these kind of heat map areas where it's getting a little bit hotter. There's going to be a little bit more light. And the interesting thing that I like to point out that maybe you wouldn't have been able to see on the image before because of that captions is that in the previous picture, you really can't see that there's a lot of light coming from this area right here. It's kind of covered up by different leaves. Yeah, you can't see it very well, but you can't see it very well. So this gives a really good visual representation of what light pollution is actually looking like and what is happening to it without just the images alone. But the great thing about this software is that we upload it into a database that generates light pollution maps from the, well, working together with ground-based sensing as well as remote-based sensing. So the ground-based sensing would be our dark sky camera. And then the remote sensing is a satellite that orbits above the Earth, which is called VIIRS, and it is the Visible Infrared Imaging Radiometer Suite. And originally this satellite was sent into orbit to image ocean currents in their different temperatures, but they quickly realized that it could have multiple applications. And so they decided to use it to study the light pollution. And this gives a really good representation of how light pollution affects areas on a map. And this can also be a really great resource for people that are looking for areas to stargaze or to camp. And then I wanted to quickly mention, I wish this captions things over here, but the Bruno Dunes State Park is around this area. Up here, there's two little dots right here. Those are the Haley, like Sun Valley Ketchum area. And then up here, that dot is Stanley. And so this area right here is the Central Idaho Dark Sky Reserve. And then that really dark spot, kind of above the Dark Sky Reserve, is the Frank Church Wilderness. And the Frank Church Wilderness is some of the most, I guess, rugged forest in Idaho. I've been lucky to raft down the Middle Fork twice now. And I have to say, when I woke up in the middle of the night and had to go to the bathroom, I was almost jump scared by how bright the stars were because it's so dark out there. So that was really an eye-opening moment for me. It made me realize that, wow, I really do want to preserve this and hopefully pass this down to my kids. So now that we've described the science and research behind my position, it's time to circle back to, my position's main function, and that is raising awareness about light pollution. So engaging with the community and turning my research into something that was digestible for the public ended up being like a really big challenge for me. As someone who was well immersed in my academics for the last 5 years, this was my first time running bigger scale events. I had served as the physics president for about 1 year, but I was in the cabinet for 2 years and we ran a few events, but those were always only about like 5 to 15 people showing up. So switching gears and having to plan an event for groups of 30, 50 to 100 people was really daunting. But as I had mentioned, raising awareness about a problem is one of the best solutions. So I approached this problem by trying to create fun and different events that I would have fun creating as well as going to if I wasn't the person, in this position. So traditionally, we ran a few stargazing nights within the reserve. I helped facilitate science talks and seminars in the reserve, kind of like what I'm doing right now. And I did a few after-school programs and even helped with a few activities for the space camp here on Boise State. But the more untraditional ones, I might have had a little bit more fun with. I did a few trivia nights at bars, as well as a Blue Moon yoga event in Avamore. And unfortunately, the sprinklers did turn on us, but everyone was a champ and it ended up being a really fun experience for everyone. Building upon this community involvement aspect, I got to be a key member of ID Astro and serve as their volunteer coordinator. So ID Astro is a collaboration between the Bruneau Dunes State Park, Boise State University, College of Idaho, College of Western Idaho, College of Southern Idaho. That was all of them. I almost blanked on that. But we have volunteers from each of these universities, and we send them to the Bruneau Dunes Observatory to help with their observatory programming that happens every Friday and Saturday. And they get to engage with the public and lead different stargazing events. And in return, we get access to their research grade telescope. Some of the research that these students help with is exoplanet transit photometry here at Boise State and College of Western Idaho, variable star photometry and galactic star formation at College of Idaho, and small body occultations at College of Southern Idaho. This is a really great opportunity for students because they get to engage with this cutting edge research while sharing their experience to the public and gaining that outreach kind of aspect that research alone doesn't give you. And this program in itself is an important first step in getting Idaho recognized as a state that can do some really cool astrophysical research. Speaking of the research, part of my position was assisting with the development of Bruneau's 27.5-inch telescope from an outreach instrument into a research capable machine. This might be a little controversial, but this was my favorite part of my position. As someone who researched astrophysics, I felt like I really was in my wheelhouse. This was something that I knew how to do very easily. And it actually was the first telescope I've ever worked on. During my undergrad, I did a lot of data analysis, but I never got to firsthand work on these machines. And so I got experience learning how to play around with different settings in a safe way. I became a Nina software pro a little bit and was able to sequence the telescope to be fully automated so that no one had to babysit it overnight. We could just go home and we knew that the telescope would put itself to bed. And during the journey, I was able to learn bits and pieces of the different research going on. And it was my first experience really working with raw data. Finally, after about 6 months of working on this telescope, as well as my predecessor working on it for about a year before me, we worked through a lot of minor problems like the focuser, but we were able to finally get usable data out of it. And about 2 months ago, I was able to successfully observe my first exoplanet transiting in front of its host star and create a light curve. So I had mentioned that the telescope was my favorite part of my job, but there were also a few special events that, held special places in my heart. So these are my special projects. If any of you have seen our calendar, you might recognize this image on the left. This is an image of the Hercules cluster, and I got to spend about 3 weeks learning how to do astrophotography and create a few images that look like that. I spent way too long sitting in front of a computer, taking advantage of the PixInsight free tutorial, and a lot of time banging my head about losing data or corrupting it. But in the long run, I got to learn a lot about how this works. And let me tell you, I have a lot of respect for people that do astrophotography now. For a really long time, I just kind of assumed that it was people slapping images on top of each other to create something that looks nice. It turns out it's a lot of data processing. So just to warn you. The final part of my project that was really special was the Sawtooth Observatory First Light. I would kind of consider this the capstone of my project. I spent about 3 months with a small team of 3 other people planning this event and making sure that it could reach its full potential. And in the end, we had about 200 attendees join us to welcome in the new observatory. And it was just really cool. It was really nice being able to come home and see that so many people had a really great time at an event that I was able to help plan. So overall, this position was a huge learning experience for me with the intention of impacting our community. I honestly believe that this position had a really huge impact on myself as well. Community-wise, I successfully held up to 15 events related to light pollution. And my main philosophy was that creating the opportunity for fun events would be the key to sharing this problem in a digestible way that would get people to act rather than, sitting here and telling you guys about it, which is what I'm doing right now. But other events and such. But personally, I believe that this position had a really big impact on myself, as greedy as that sounds. Before this position, I had never done any form of outreach, and it was a really big learning curve for me. At first, I really thought that I wasn't cut out for it. I didn't know if I could do it. But slowly, I learned that I am capable of doing these things that I had previously determined for myself that I couldn't do. But it turns out that's not true, and you can learn to do really cool new things. Alrighty, well, thank you for attending my talk tonight, and I really appreciate all of you guys taking the time out of your busy schedules to come listen to me and learn about my position.
Oh, there it goes. Yeah, right there.
You talk to any local city councils like Boise or Colorado or Tennessee? You talk to them about things they could do to mitigate this problem and maybe correct some of the data?
I personally have not. As kind of as part of my AmeriCorps position, I guess I'm not really allowed to talk much about I guess legislature or really impact things that way. The main goal of my position really is just to educate. If anyone or like state officials were there and were moved by my events, then that would be great. But that's really the way that I would have to impact them. Yeah.
Right.
It looked like there was two different colors being submitted, like beige. Oh, is that the very last one?
Or is it this one? This one?
Different colors.
I think.
Leah, would you repeat the question for folks on the
Oh,
back too?
yes.
Sorry.
So the question was on this picture, there's a little bit of a purple emission. I think you're talking about the purple emission kind of at the top. Yeah. And then kind of on this side, there's a little bit of a green. If I had to make my best assumption, I think there might have been a little bit of aurora that night. And so there might have been a little bit of that like red kind of purpley coming in from the top. And then over here is where kind of that sky glow was. And it's kind of hard to see, but there's a little bit of like cloud fog right here. And so I think what was happening was some of that light was hitting these areas and kind of creating that weird like eerie glow. Yeah.
Recently, that the problem with LED lights is that they save money, and cities like it. And they would normally produce less light, but because they're cheaper, the cities keep them on longer and put them in places. So is that really the problem with LED or?
Yeah.
Should I repeat the question?
Yes. Okay. So the question was, with the implementation of LEDs, cities are keeping them on longer and they produce a lot more light. And is that the main issue with the LEDs? With LEDs, there's a few different problems. The LEDs that we mainly produce that are super cheap, those end up being really close to the blue side of the spectrum. And Rayleigh scattering kind of like those molecules in our air really resonate with those blue temperatures. And so it travels a lot further. But yeah, I guess, yeah. So the problem is one, the temperature, and it is also that brightness factor. So they're really cheap, they're really bright, and they can't really like fluctuate that brightness very much up until recently. And so all of those kind of older implemented LED lights that will last forever are kind of those like really blue, bright ones. And so that ends up being the problem where there's just so many of them and cities are like, well, they're going to last forever, so we'll just leave them. But yeah, that's a good question.
Yeah, in the back.
Or
how would they cut down on those? Because all that comes from like those cars driving around, the lights on, like, how do they, kind of, I would really not if they cut back on those.
Yeah. Okay. So the question was, how would really big cities sufficiently cut down their effects of light pollution? The honest answer is they can minimize it. They probably won't fully neutralize it. Things like headlights and stuff like that are always going to exist. But the best way to minimize it would just be to change light fixtures. So have them facing down so that they're not pointing straight up. Of course, some of that light is going to reflect off of the ground and come back up. So we won't be able to completely get rid of it. So I don't think there will ever be in the future, unless all the power goes out, where you'll look down from a satellite and not see any lights. But the effect of it turning into sky glow can be minimized by having it point straight down, turning it to like a warmer temperature of light, and all that good stuff. Yeah.
How much of a difference does it make if I go higher where there's less atmosphere? Higher?
Okay, that's a good question. So the question was, how would light pollution differ changing from a higher elevation where there's less atmosphere? I'm going to be honest, I don't really know. I believe most of the Rayleigh scattering that happens, at least during the daytime, happens in that upper atmosphere. And then it loses, like it stops scattering once it gets further down. So I have a feeling it wouldn't change much. But that is a really good question. I'll have to look into that. Yeah, yeah. Put me on an air balloon and I can check it out.
Yeah, your instinct is exactly right. What Leah's saying is right. Your instinct that if there's less atmosphere above you, there'd be less Rayleigh scattering. Totally right. But one of the problems is to go up high enough that you would get very little scatter from the atmosphere would probably make you asphyxiate.
That too. We might not live up there. Yeah, so dark sky communities are places where it's not necessarily designated. These are just communities that have made a pact to like their development. So every house that's built, make sure that it has dark sky friendly lighting fixtures. And I believe there's a few that I know of. I know Avamore is because my dad works there. And then Sun Valley in the Ketchum area, those are dark sky communities as well. And it really is just like, I believe it's like an internal structure that they themselves have decided that all of their lights will meet a certain regulation. Yeah.
Let me get a question here from online. How does someone get involved in doing what you do without the legislature restrictions? Is there something that will, let's see, is there something that will accept volunteers to help battle the legislature side of it? So how would you advocate for?
Yes. So my position is a little bit unique. But there are groups, I believe. The Audubon Society is a really big group that advocates for reduction of light pollution. They're mainly focused on birds. It's their thing. But joining groups like that, I know that there are groups, especially in Salt Lake City, where they do a lot of this tracking and advocating for things like this. I don't know of any in Idaho. I had talked to oh yeah. The Idaho Dark Sky Alliance that I work for. They are a great place. They actively advocate for our dark skies, and they are able to do the regulation side that I cannot touch. Yeah.
IdahoDarkSky.org.
Yes.
Other questions? All right, in the back there.
Report or course of action to be achieved by these purchase of dark skies
I know that's popular in some areas of the Southwest.
Oh wait, okay. The question was if there were any acts, I guess, within Idaho, for dark sky easements. Was that correct? Yeah. That's a great question. And I honestly have not looked into that. I haven't heard of, what a dark sky easement is. So that's a really good thing for me to look into. But if I had to kind of take a guess, I would want to say yes. It seems like people out here really do care about their night skies and protecting it. So I have a feeling there might be some out there, but I'm not totally sure.
And the dark sky, the Central Idaho Dark Sky Reserve that Leah was talking about, that is national forest. And so there's a lot of effectively what you're describing, sort of federal easements in that sense. So there's not development allowed in a lot of that area. But in terms of private easements, I'm not familiar with any efforts within the state. Is there a question down here? Okay. All right, well, let's thank Leah again. And thanks so much for coming out. Join us again in September when we'll have Jack Kirley from the